Fahad,
No, ma'am. Exams are finished.
exams are finished, no? You were absent, no? I think in the past 2 classes.
Yes, ma'am. I was not getting time to attend classes.
Okay, class. So in the last class, we had started with Young's double slit experiment. So far, if any video lectures and all have been missed, just please keep on tallying in with that.
Ma'am, we finished this ray optics.
Ray optics we had completed. We are on Young's double slit experiment. In the next class, we'll be able to finish with wave optics as well.
Okay.
Right? We did the equation of the resultant wave, that was r y is equal to r sine omega t plus theta. Now see, here we had taken a plus b cos phi as r cos theta and b sin phi as r sin theta. See, if we square it and add it, we can get the amplitude of resultant wave. Right now, we are just considering that amplitude of resultant wave is capital R. Yes, others were present. Priyadarshini was present. Donna has also come after a long time. Or Donna was present in the last class.
I did miss a few classes.
Missed classes, no? Yes, your classes have also been missed. Okay, Donna. Do check the video lectures because we are directly on wave optics now. So yes, Priya, Rifat, I think you were there, you'll be able to recall it. We did this equation, so we just wrote amplitude of resultant wave. Let's see what will be the equation of resultant wave. If you have A as amplitude, B as amplitude, if you know both these amplitudes, how will you now solve further? So for that, we'll square and add it, both the two equations that we have got. So A plus B, see A plus B cos phi whole square plus B sin phi whole square. Both the LHS left hand sides I have added. Now I'm adding the right hand sides. That is the r square cos square theta plus r square sin square theta. Now let's open up the brackets at least. A square plus B square cos square phi plus 2ab cos phi plus b square sin square phi. This is equal to r square common cos square theta plus sin square theta. Fine. Now from here, C class. If we take b square here, b square, let's take b square common from both of these. So a square plus b square. From this part, you will be left with cos square phi. Plus from here, you will be left with sin square phi. Plus 2ab cos phi, which is equal to r square into this entire term. Now see class, whether it's sin square theta plus cos square theta or sin square phi plus cos square phi. This term is also equal to 1 and this term is also equal to 1 by this trigonometric identity. Sin square theta plus cos square theta is equal to 1. So cos square phi plus sin square phi is also equal to 1, anything. So cos square x plus sin square x is actually equal to 1. So you are left with a square plus b square plus 2ab cos phi is equal to r square. It's similar to the parallelogram law that you have did in your class 11. So r is equal to under root a square plus b square plus 2ab cos phi. This is the final amplitude of the resulting wave. This is the amplitude of the resulting wave. So if you have two amplitudes with you, r, that was what was we were depicting. So now r's value is given by this. Also, if you have to find out the direction, just divide. Same thing. This is exactly amplitude part and the direction part is similar to parallelogram law. So here you have b sin phi. If you divide it by a plus b cos phi, this will be equal to r sin theta by r cos theta. R getting cancelled, tan theta will be equal to B sine phi by A plus B cos phi. This does not get used so much. This equation is important. This equation gets used. Fine. Note down this amplitude part. Priya, yes, I'll be sharing for all the questions, for all the lessons, not just for current electricity. Let us just wind up with this lesson and one or few lessons, then I'll be sharing those things with you. Yes, Fahad. Now after ray optics, no, rest of the lessons are easy only. Level of difficulty will keep on decreasing as you reach the end of the second book. Done all. See, class, in the last class, I had told you intensity is directly proportional to square of amplitude. We didn't do any derivation. I had told you that you have a separate formula for the resultant intensity also. Individual intensities, you know. Intensities of the wave individually, you know. If amplitude is A, it will be directly proportional to A square. If amplitude is B, it will be directly proportional to B square. If amplitude resultant is R, it will be directly proportional to R. Remember, here we did it, class. Here, yeah, this part. Intensity is always proportional to the square of the amplitude. All right, class. So see, intensity of the resultant wave, if you have to calculate. See, so intensity will be directly proportional to the square of the resultant amplitude if I'm calculating the resultant intensity. So amplitude also I have to take the resultant. So IR will be equal to KR square. IR, resultant intensity, is directly proportional to square of the resultant amplitude that you have. So resultant amplitude's value you already have from the equations which we have just derived. R value you have derived. Put it in here. R value is under root A square plus B square plus 2AB cos phi. Put it under root, you get under root A square plus B square plus 2AB cos phi. Square gets cancelled. You are left with just this term. Let's expand it further. Let's multiply K within this bracket. So see, resultant intensity will be Ka square plus Kb square plus 2Kab cos phi. Class, tell me one thing. What is root K into root K? Root K multiplied by root K. K. Good. Priya and Fahad, it is K. So it means I can replace this K also in the middle that I'm getting by root K into root K. See, this will be Ka square plus Kb square plus 2 root K into root K. Just this is the K part only which I'm writing. AB cos phi. Fine? Root K AB cos phi. Now class, one thing. I1 is equal to Ka square. Intensity of the first wave which is having the amplitude A. Intensity of the second wave having amplitude B will be, let's say, I2, which is Kb square. Fine? Now class, if from here you write the values, you take square on both the sides. Take squares on both the sides or roots on both the sides. So this will be root I1 is equal to root K into A. Similarly, root I2 will be equal to root K into B. Do you all agree till here? I1, I2, value of both the intensities. Now see, class. Look here. This is Ka square, the intensity of the first wave having amplitude A. Can I replace it with I1? Ka square is equal to I1 only. Similarly, Kb square. Can I replace it by I2? And look here. Let me write it till here first. See, I resultant will be I1. Ka square can be written as I1 plus I2 plus. Now see, let me write 2 first. Now look here, class. root k multiplied by a. Can you see root k multiplied by a? Root k multiplied by a, that is root I1. Same thing, root k multiplied by b, root k multiplied by b, that is root I2. So root I1 into root I2, and now what is left? Cos phi. This is the intensities equation. Intensity of the resultant wave. Like this, you have to calculate it. Understood? How did we calculate it? K1, Ka square was I1, Kb square was I2. So I1 and I2 we wrote. 2 and cos phi remained as it is. Instead of root Ka, I wrote root I1, and root Kb, I wrote root I2. Note down this equation, then you have a few important things, condition of maxima and minima. That we'll do. First, note down the intensity part. So how many things we have covered? Equation of the resultant wave we did. After that, in today's class, we had started with amplitude of resultant wave, theta, tan theta's value, that is the direction, and intensity of the resultant wave. So now maxima, minima, that is constructive and destructive interference are left. Note it down, then we'll see that. Yes, Fahad, that's why I want to. That's why I'd increase the duration of the class as well, so that we can complete it fast. And because for the revision, no, we'll be completing and covering the PYQs. Theory part also we'll do. Numericals from previous year questions we'll see. C class. Now condition of maxima. Maxima basically means bright fringe. So in your exam, bright fringes, we had studied the entire Young's double slit experiment. So there we had seen central bright fringe was obtained. Then we had dark fringes, then bright, then dark, then bright on the either sides of the central maximum. So what are the conditions? Like this was theoretically we had seen that yes, central one will be bright. On the sides you will be having dark. Then on the sides you will be having bright. On the other sides you will be having dark. Mathematically, how will you use it in your equations, in your numericals? So remember, for maxima class, everything will be maximum. Intensity will be maximum. Amplitude will be maximum. All these values will be maximum because you're getting bright fringe. Intensity will be high. Amplitude will be high. So see, resultant amplitude will be maximum. So cos theta will be +1. So for cos phi to be 1, phi's value can be 0, cos 0 is 1. It can be 2 pi, it can be 4 pi, it can be 6 pi, 8 pi, 10 pi, like this, all the even multiples of 2. So that means that makes it up to 2n pi. Multiply any number with n. See, so phi becomes 2n pi actually. Your phi is 2n pi. So your n is 0, 1, 2, 3, and any number from this. Fine. If you put 0, you get phi as 0, cos 0 degrees 1, you already know. You put n as 1, you get cos as 2 pi, cos 360 degrees also 1, you know. Similarly, put 2, you get 4 pi. Put 3, you get 6 pi. Put 4, you get 8 pi, and all the even multiples. What was phi, by the way, class? We had a name for this. Phase difference. This was phase difference. So phase difference is 2n pi. Remember or not? Phase difference we had. Now see, path difference also we had studied. And there was a relation between path difference and phase difference which we had seen. Phi by 2 pi was equal to x by lambda. Remember? This we had seen in the last class. Now see what is the path difference for bright fringe. Right now I'm talking only about bright fringe. Everything that we had studied in the last class was generalized. It was generalized. It was generalized. Now we are having a specific value that we know that we are just having it for bright one. So put it. So 2n pi by 2 pi is equal to x by lambda. Pi, 2 gets cancelled. X becomes equal to n lambda. N is again 0, 1, 2, 3, any number. X is equal to n lambda. So path difference is n lambda. Phase difference is 2n pi. If you have to write the maximum amplitude, see R max will be what? Put cos phi as 1. See what answer you're getting. A square plus B square plus 2AB cos phi. Put cos phi as 1. So you will be left with under root A square plus B square plus 2AB. Can I write A square plus B square plus 2AB as A plus B whole square? With an under root is there. So under root cancels this power 2. That means R max is equal to A plus B. So if you know this is the case for bright fringe, directly write it as A plus B. If it's the case for bright fringe, no need to solve anything, no need to put anything. Same way, intensity was square of the resultant. So intensity, resultant intensity will be square of R max, that is the resultant intensity will be K A plus B whole square. That was equation of resultant wave, equation of resultant amplitude, equation of resultant intensity generalized. Now we are seeing it specifically for bright fringe only. So this is for bright fringe. Note down this case for bright fringe. Similar case we'll observe for dark fringe only. Class will end at the usual timing, Fahad, the way we had the earlier classes. 8:30 to 10:30 is the IST timings. See class here. Now you just have minima. So everything will be negative. That is, will be minimum. Intensity will be minimum. Cost value will be minimum. So see here, some differences will come. See, cost phi will be -1 because this is minimum value. So you will get, now you will not be having even multiples. You will be having odd multiples like 3, 5, and also it will be 2n minus 1 this time. So this is 2n minus 1 pi this time. 3 pi, 5 pi, like this. And n also cannot be 0 because if n is 0, you will get it again as cos 0, which is 1. So see, this will be phi will be equal to 2n minus 1 pi. This is the value of 2n minus 1 pi. This will be the difference that will be seen everywhere. So here also this won't be just 2n pi. So this is 2n minus 1 pi divided by 2 pi. So pi gets cancelled. So x becomes equal to 2n minus 1 lambda by 2. This is the path difference. Now see, cos phi will be -1. So here when you will see the identity, so see, this will be -1. Here also minus, here also minus, minus. So instead of maxima, you will be having everywhere, you will be having a minima. So this will be R minimum. So intensity will also be the square of the minimum value. That is, this will be minus A minus B whole square. This will be A minus B whole square. So same things that you have with destructive interference. This is all about dark fringes. So same thing. Noted down. Yes, just a sign change. Fahad, did you understand? Light that is formed, that part, did you understand? Fringes. Okay, fringes part, class you didn't attend, no? YDSE. Slits are there. Wave, two waves are superimposed from the to both the slits. Wave come when they superimpose each other. If both the crests in superimpose with each other and the trough superimpose with each other, that leads to increment in the intensity, increment in the amplitude. That is known as constructive interference. There you get bright light at the center. Then besides it, you get bright light. Those are known as bright fringes. And wherever they are destructively interfered with each other, it means that destructively interfered means what? Destructively interfered means that they, all these waves, the crest is either overlapping with the trough this way. So that way you do not get any colored fringes. That is known as dark fringe. Now see class, these questions, these types of questions are there. Two waves in YDSE have amplitudes A and 2A. Ratio of intensities from two waves, amplitude. First, let us see the first part. Ratio of intensities. You have amplitudes, you have to find out ratio of intensities. I hope this is not difficult for anyone. See, intensity 1 will be Ka square. Intensity 2 will be K. The second intensity is 2A whole square. First amplitude was A, second amplitude was 2A, right? You have to find out the ratio I1 by I2. Ka square by K, 4A square. So A square gets cancelled, K gets cancelled. So I1 by I2 is equal to 1. 1:4 is the ratio that you get. Second part. Amplitude of resultant wave is if phase difference is pi by 2. Phase difference is given, amplitude of resultant wave. A you know, B you know, A is A, B is 2A. Phase difference phi you know, simply you have to put it in the formula class. This is a good question from the application perspective. See, resultant amplitudes equation is A square plus B square plus 2AB cos phi. A is given as A, B is given as 2A, and cos phi is given as pi by 2. Kitna tha? Yes, pi by 2 it was. Pi by 2. Put it in all the values, you get A square plus 4A square. Pi by 2 will make it ultimately 0. 2AB into cos 90 degree. That will be under root 5A square only. So A you can take, root 5 will be left. A root 5 will be the answer, right? Last part said that, see, you still have to find the same thing, but now phase difference is not given, path difference is given. Now in this case, what will you do? Same question, the way we had the second part, but phi is not given, x is given. Remember we had a relation between x and phi, phase difference and path difference, that we'll use. This phase difference divided by 2 pi. Phase difference we do not know. X is given lambda by 2. Right, x is given. If you notice here, in the question it is given lambda by 2 divided by lambda. So lambda gets cancelled. 2 gets cancelled. Phi you have as pi. So now the question is similar to the previous part. You have A square plus 4A square plus 2A, not B exactly. Instead of B, we have 4A. Sorry, 2A. So A square plus B square plus 2AB. So 2A into B is 2A. And cos 180 degree, that is minus 1. So this will be 5A square. Here we have 4A square minus 4A square. That will be under root A square only, right? So that will be A. All right, class, note it down. Any difficulties you have, please let me know. Those who were not present, if you're still not able to understand anything, please let me know. I'll repeat it.
Recording in progress.
Slit means cut. From a big screen, cut is there.
I'm gonna scroll up.
Now C class. This was about the basics of interference, constructive and destructive. Let's go into the details of this fringe. Expression of fringe width in YDSE. Fine. Fringe width we'll see later. Let us first calculate the central bright fringe separation. C class. What happens? First, the central bright fringe is formed. Let me show you here. At the center, a very bright central fringe is formed. Then on the sides of it, darkness is there. Means dark fringes are formed. Like this. Then again on the either side, this one is the central one. Aside from the central one, these are formed. Like this, and so on, it will keep on moving. So this central one that is formed, this is known as central bright fringe. These are not gray or yellow, white colored. Simple bright light, laser light you will use, bright fringe you will get, red lights where there won't be any light, that will be dark fringe. So this is central bright fringe. This is first dark fringe. This is first dark fringe. First dark fringe on either sides. First bright fringe. First bright fringe. Then you will get second dark fringe. Second bright fringe. Third dark fringe, like this. Now, if we want to calculate separation of any of the fringes, let's say this first bright fringe from the central maximum. So what will be the formula? That we are deriving. This is Yn, separation from the central maximum. That is what is the distance we are calculating. So see, this is two slits we have taken. Screen is placed over here. At this screen is there. At the center, you're getting central bright fringe. This is capital D, distance between the screen and the slit, and small d, separation between both the slits. Separation between both the slits is small d, and separation between the screen and the slit is capital D. Now class, S is the source. D, let's say from the middle, I have divided it into D by 2 and D by 2. Where the central bright fringe is formed is exactly at the center. So this part will be Yn minus D by 2, whereas this entire long part will be Yn plus D by 2, right? Yn is this, so plus D by 2 for Pm and Yn minus D by 2 for Pn. Understood? Now we have to calculate this linear separation Yn. To start with it, no. Path difference will be what? As discussed earlier, only path difference will be S2P minus S1P. So what is the value of S2P? What is the value of S1P? We'll calculate it from using this triangle S1PN. Understood? Use this triangle S1PN and see the value. Use S2PM triangle and see the value of S2P and then put it in X. C class, what I'm saying is, for this derivation, no, see, this is a derivation, you have to practice it. X is equal to S2P minus S1P. This is the path difference. Fine, S2P minus S1P. How will we write S1P? So from triangle S1NP, the above shorter triangle that is formed, we can use Pythagoras theorem and write S1P, that is the hypotenuse. S1P whole square will be equal to S1n square plus Pn square. Now see, S1P whole square will be what? S1n is this separation. Let me show you the front paper. See, S1n is this capital D. Fine, this is S1n. And Pn is Yn minus D. So let's put it. This S1n, this will be D square. This will be Yn minus D by 2 whole square. So S1P will be D square plus Yn minus 2 D by 2 whole square to the power half, because this square I have taken it on the other side. So S1P will be d to the power d square, you can take it from the bracket to the power half and 2 will get cancelled. T will be left. From here, you will be left with 1 plus yn minus g by 2 by d square. D square, if you take common to the power half, class. Can you see binomial expression over here? See class, for d, no, it is like d square I have taken common and half was already there. That's why I'm getting the value of S1P as d, 1 plus yn minus g by 2 by d square to the power half. This is forming a binomial expression. Binomials are exactly 1 plus x to the power n. This becomes equal to 1 plus nx. So same thing here will be applied. S1P will be equal to d, 1 plus half, because power was half, n was half, so nx, power is half, and your x is yn minus d by 2 by d square whole square. Fine? Same thing, we'll take it for triangle 2. This is the value of S1P only till now. S2P is still missing. S1P I have calculated right now. S2P will be calculated from the bigger triangle, S2PM, that longer one which we are getting. So same thing, S2P whole square, if you apply Pythagoras theorem, will be S2M square plus PM square. See, S2M is again this separation, capital D, and PM, the longer one, yn plus d by 2, which we have calculated. So if you put S2P whole square will be d square plus PM whole square will be yn plus d by 2 whole square. Right? Yes, whole square. So same thing, same steps are getting repeated. D square plus yn plus d by 2 whole square to the power half. See, same things. We're just trying to find out the value of S2P. S1P we already calculated. If you use again binomial, expression, so S2P will be, D will be taken common, 1 plus half yn plus d by 2. This is just the difference that is arising with plus and minus, plus d by 2 whole square by d square, right class? Now you have value of S2P from here. You have value of S1P from here. Can we put it into this equation? X equals to S2P minus S1P. Now put it in this. See, this is what we are calculating. X will be d, 1 plus half yn plus d by 2 d square whole square minus d, same thing, 1 plus half, but yn minus d by 2. Both the equations, simply I'm just putting it into the equation. So from here, half minus d minus 1 plus 1 will get cancelled. Half minus half will get cancelled. So we can take d is already there. 2d square we can take common. 2d square we can take common. So we are left with yn plus d by 2 whole square minus yn minus d by 2 whole square. Rest of the things will get cancelled only. Now see, and also this d is getting cancelled with this square. So x is equal to 1 by 2d. Open up the brackets, yn square plus d square by 4 plus 2 into yn into d by 2 minus yn whole square minus d square by 4 minus 2 into plus into 2y into by 2. So this gets cancelled. It's a very long derivation, but if you simplify, break it into parts and then only study, otherwise it will become very difficult to understand. So this is what are we left with? 2yd and 2 times it will become, no, 2 times. So 2yn and these two also will get cancelled. So 2yd, ynd plus ynd will be 2ynd and divided by this 2d. 2 gets cancelled. X is equal to yn small d by capital D. What we were calculating? We were calculating the value of yn only, the separation from the central separation from the central maxima. So that will be x capital D by small t. First, tell me, something is clear or not? Understood or not? It's a lengthy derivation, but process-wise, did you understand or not, class? S1P, you calculated it from the first triangle. Second one, you calculated it from the second triangle. X value you put, you solved it mathematically, simplified it, and got the value of yn. Something understood, Fahad? Do one thing, class. Start noting it down. Whichever step you're not able to understand, because this is a very lengthy derivation. I tried to make it concise, but it is very lengthy. We have 3 steps. See, class. X is S2P minus S1P. S1P's value calculated from this triangle, put it. Calculate value of S2P from this bigger triangle and put it. Fine? Then you simplify, get a relation between yn, capital D, small d, and x. Note it down. Wherever you're not able to understand, you are free to ask. I'll repeat it because it is lengthy, I understand. Separation from the central fringe to any of the fringes, not between any two, just from the central fringe. See class. Now after this, if we put in the values, let's say this is just an example, bright fringe. So for bright fringe, you know, x is n lambda. So yn will be n lambda d by d. You had x capital D by small d, no? So this will be n lambda capital D by small d. So if you put in the value for first bright fringe, you will get it as lambda capital D by small. Second bright fringe, 2 lambda d by d. Third bright fringe, 3 lambda d by d, and so on like this. And if you write it for dark fringes, you will be having yn 2n minus 1 lambda d by 2d. Whatever you've studied, same thing if you will apply. So first dark fringe will be lambda d by 2d. Second dark fringe, that will be 2 into 2 minus 1, that is 4 minus 1, 3. 3 lambda capital D by 2d. Again, if you take n as 3, so that will be 5 lambda d by 2d. And so on like this. Now, whatever value you can calculate for any of the values of lambda. One more thing, class. Width of fringe is what we have not done. Width of fringe means this is what you were referring, Fahad. Fahad, you were saying, no, referring to this point. Separation between fringes. So if you want to calculate the separation between the fringes, width of the fringes, let's take dark fringes. If you are calculating for the dark fringes. So it will be, let's say this is the dark one and the one just beneath it. That will be the dark fringes. So yn minus 1. Separation between two consecutive dark fringes or two consecutive bright fringes is width of fringes. Fine? Like this is dark, this is bright, this is dark, this is bright. Separation between two consecutive dark fringes, this is known as fringe width. Separation between two consecutive bright fringes, this is known as fringe width. So beta, yn you have calculated. I have just shown you 2n minus 1 lambda capital D by 2d minus 2n minus 1. Instead of n, I'll be writing now n minus 1. So 2n minus 1 lambda capital D by 2d. Instead of the way we write 2n minus 1, so that n is n minus 1 right now. So see, beta will be 2n minus 1 lambda by capital D by 2d minus this entire term 2n minus 2 minus 1 lambda capital D by 2d. Now let's take lambda common, lambda capital D and 2d we can take common, no? So lambda capital D by 2d, from here you are left with 2n minus 1, from here minus 2n plus 3. So this will be 2n, 2n gets cancelled, 3 minus 1, 2. So that 2 will cancel this 2. So you will left with beta is lambda d by d. Fahad, you got disconnected. So your network issue fine. No, he's still having issues. All right. So this is what is bright fringe. Fine. Even if you calculate it with the help of bright fringe, you'll get the same answer. If you calculate it with the help of dark fringe, you will still get the same answer. Note down these 2 points, then 2 more points I have to discuss that I'll see. First, note down from here. C class. One more thing regarding angular fringe, now very small topics are there. Central bright fringe, let's say this is this much thick, central bright fringe. So from the edges, if you will see at the slit center, it will be subtending some angle. That angle is known as angular fringe width. Fine, that is known as angular fringe width. So this angle that is subtended by the central bright fringe. So this is given by theta is beta. Beta is fringe width. Just now we have written by capital D. Capital D is see capital D and small d. These two quantities will remain fixed. Fine, capital D and small d, these two quantities will remain fixed. Small d will separation between this and capital D will be separation between screen and the slit. So beta by D. Even if you keep put the values of beta, lambda capital D by small d into d. So value of theta becomes lambda by t. Fine, this is angular fringe width. One more thing, class. If this entire setup is being done in air, suppose we take this entire setup and immerse it into some other medium having refractive index. So if the medium gets changed, see beta in air is lambda capital D by small d. Beta in any other medium will be this entire thing divided by the refractive index, if refractive index is n. So it means beta in air, that is fringe width in, not in air. Let's write it for some medium. Beta for some medium will be beta in air divided by the refractive index. Class, can you tell me? This is beta in air. This is beta in the medium. Is beta in the medium getting decreased or increased because of refractive index? Increased or decreased? Decreased. Good, Priyadarshini. Priya is always active in the class. Yes, this decreases because it is getting divided in the denominator. So it will decrease. All right, note down these small points as well in fringe width and regarding the refractive index. Okay, class. So all those who have completed, you all can leave. We'll complete this chapter on Thursday now. Okay, same timings. Thank you so much, class.
Thank you, ma'am.